Implicit differentiation question, you have this function x squared y minus x over y equals -2. And the number one thing with this really is just paying attention and just being methodical. It's very easy to get the sign wrong, and these answer choices are all very similar. So we have to be very careful with how we choose, how we distribute, and how we do this. I mean, it is a testament to our differentiation ability, but overall it's algebra and like bookkeeping. So what do we want to do here? First, we want to realize that this first term here, in order to differentiate implicitly, you need to use product rule, where this is like f and then this one is like g. So what does product rule say? F prime times g plus g prime times f. So now what is it? So f prime is 2x. That's this part. Times y is g plus g prime is dy dx times f is x squared. And I've differentiated this first term. Now minus. I'm going to put everything in minus here and then equals. So I'm going to differentiate this and I'm going to remember to distribute this minus correctly. Equals. The derivative of a constant is 0. And now let's find the derivative of this. But this you have to use quotient rule. Quotient rule says f prime times g minus g prime times f, all of it, divided by g squared, the bottom function squared. So what is it in this case? It's 1, because the derivative of f in this case, which is x, is 1, times g is y, minus g prime is dy dx, and then f is just x. And I get 2xy plus x squared dy dx. Oh, wait, what did I forget? Divided by y squared. Don't forget that. Minus, and I'm going to distribute the minus and also put this in each piece. So it's going to be 1 over y plus dy dx times x over y squared. So I split up the numerator and I distributed the minus. Equals 0. Now I want all the terms with dy dx on one side and then everything else on the other side. So that means I want to get this on one side and this on one side together, and then move everything else over. So when I move everything else over, I get 1 over y minus 2xy, and then on this side I got the x squared dy dx plus x over y squared dy dx. And I'm going to factor out a dy dx from here, dy dx. And right away, what I realize I'm going to need to do is I'll have the x squared plus x over y squared inside here. But what I want to immediately do is actually get a common denominator, because I need to get what I get for dy dx to match one of these choices here. So because of that, I need to make it look a little nice. Now I could just write x squared plus x over y squared. Right, so I'll do that intermediary step for you so you see what I mean. And then now what I was going to do in one step was that what I now have to do is I have to get a common denominator between x squared over 1 and x over y squared. And that's y squared. So I would multiply that term by y squared on the top and bottom and get x squared times y squared plus x over y squared, the whole thing, equals, and I want to do the same thing over here. I need to get the common denominator as being y, so it's 1 minus 2xy squared over y. And now when I divide, I want to change flip, so that way I get dy dx is equal to, when I change flip, right, I'm dividing this by this one, The y squared is going to come up here, and then the x squared y squared plus x is going to go on the bottom. So this y is going to cancel with one of those, and I'm left with 1 minus 2xy squared times y over x squared y squared plus x. And now this I could correctly identify, I believe. If I distribute the y in, I'm going to get y minus 2xy cubed. Okay, so it's between b and d, right? Because they both have the same numerator, which is equal to mine when I distribute the y in. And then I have a plus in the bottom. So it's going to be x plus x squared y squared. And b is my choice. And literally the difference between b and d was just that sign change. So we have to be careful when we're doing this, because even just that small sign change can make us put the wrong answer. So take your time with this. Be methodical.